So this is familiar territory for a lot of you, but for some of you it's the first time you will have seen it. We're going to talk a little bit about the Regional Integrated Assessment crop modeling protocols and the process. So the core questions that we're trying to answer in the Regional Integrated Assessments are shown here. First, what is the sensitivity of current agricultural production systems to climate change? We've added a new question. This is a kind of a minor tweak on the questions we've already answered, but it is, what are the benefits of climate change adaptations on current production systems, assuming the current climate? And the second question, what is the impact of climate change on future agricultural production systems? And finally, what are the benefits of climate change adaptations on future agricultural production systems? So this is a schematic of the big picture of the regional integrated assessments. We start with climate data from various RCPs, or representative concentration pathways. Those are fed into the crop model and crop models and livestock models. These are multiple models, so the AgMIP protocols emphasize the use of multiple models throughout the process. And the outputs from the crop and livestock models are then fed into regional economic models, and finally the economic, environmental, and social impacts are assessed. For the FACEIT platform, we're dealing only with the crop modeling portion of the analyses, and actually not even the entire crop modeling process, because we're assuming that the data are prepared as you've been doing in phase 1 on your desktop using Quad UI and AgMIP UI in the domes. So for the case study that we're presenting today, we have gotten data from the Chihuahua team in West Africa, and we really want to thank them for allowing us to use their data in this demo. We're looking at the maize data only. There are 100 sites surveyed in 2007. We're going to be showing both DSAT and AppSim crop models running on the FACEIT platform for one climate scenario, 5 GCMs, and one adaptation scenario. So a little bit of review here on the data types used for the RIA demo. Survey data, you're familiar with this, also known as the ACE data, AgMIP crop experiment data. This is the harmonized data format that forms the input to the crop models. We have, in this demo and in phase 2, we want to separate out the weather data from the survey data, and the reason being that every scenario that you look at, it requires different weather data. And so we're considering that to be supplemental data. Cultivar data is also considered to be supplemental data because it is model specific. Dome data, you're familiar with the domes, the field overlay, and the seasonal strategy. The next slide talks a little bit more about those. One thing that's a little different about phase 2 and how we're doing things, even with the desktop applications, we are separating out the linkage between the data, the survey data, and the domes with the use of a linkage file. That way that survey data can be reused for each of the analyses rather than embedding that linkage data in with the survey data. And then we have the ACMO data, the AgMIP crop model outputs that everybody's familiar with. Okay, so a little bit about the domes. The domes have several uses. I've listed 3 of them here. Field overlay domes are used to fill in missing data prior to data translation so that all the models use the same assumptions. So the idea is that we take the ACE data, we apply any information that was not recorded in the field but is required by the crop models. We put that in the dome, we apply the dome data to the ACE data, and that combined data stream is what is sent to each one of the crop model translators. Seasonal strategy domes allow us to take that single year of survey data and synthesize multiple years of crop management. So it applies planting date rules, we can specify what the CO2 concentration is, and other things. The third use is to use the domes to apply a hypothetical management regimen, and this is how we would apply the adaptation packages, such as new fertilizer rates or different cultivars and so on. So to do the integrated assessments, we need these different crop modeling simulation sets. So I've got the historical simulation that's kind of outside the box. That's done first just to assess existing conditions as they were surveyed. And the integrated assessment itself has the 3 simulation sets that include current climate, current production, future climate with current production, and then finally the climate adapted production systems with both current and future climate. So the historical simulation used for model validation, computation of biases, and probability of exceedance analysis is going to use the survey data. And the field overlay is going to fill in that missing information. We use a linkage file to tie the 2 together and use the current climate. So simulation set 1 for the integrated assessment, current climate, current production system. We use the same survey data, same field overlay, and now we're going to apply a seasonal strategy file or a set of seasonal strategies that will allow us to synthesize that 30 years of yield data so that we get the climate variability impact. And then a linkage file which ties the domes to the survey data. Simulation data set 2, future climate, current production systems, use the same survey data, same field overlay. Now we have seasonal strategy files, 1 for each of the climate scenarios, or GCMs. And similarly, we have the future climate, the daily weather data for each of the GCMs, or climate scenarios. And we have a linkage file that combines the data for each. Similarly, simulation set 3, same type thing, but here we're applying adaptation. So we have the combination of adaptation and climate scenarios, which gives us even more simulations that need to be done, assuming multiple adaptation scenarios. So we end up with a lot of simulations. It's enough to turn a mild-mannered crop modeler into a raging monster. And so I've just done some calculations here for a typical regional integrated assessment. Might take as many as 2 million simulations, and that's if everything goes right the first time, which, as you know, rarely happens. You know, you might make one minor error in the data and you've got to rerun everything. So this presents a really good case for having an automated way to link these modeling chains together and allow us to do these many simulations easily. So with that, I'm going to turn it over to Joshua, who's going to tell us a little bit more about the basics of the FACEIT system and what it can do for us.